Good afternoon, this is Ben K4ZEP. Got things optimized a little bit more as far as placement, learning how to adjust the motor. Just sitting here, you see it'll rock back and forth. If everything's right, it'll just rock just as pretty as it can be, and if you just give it, sometimes it'll kick itself in, but I'm running on only 12 volts now, so it doesn't often kick over. But watch, if I just give it the slightest little spin, it'll start running now. Let's let it come on up to speed, which will take a while. And in the meantime, while it's doing that, let's look at the waveforms here. Top waveform is the current through a 0.1 ohm resistor. Bottom waveform is the voltage. Someone asked me to pull the diode across the coil. If you do that, you can see. Get the hand out of the way. You can see the. Oops, twisting the wrong thing here. Always the story of my life. You can see the back EMF pulses. Just turn the brightness up so you can see them off the coil. And they're there. You can see it very clearly at times wandering across the screen. Let's put the diode back on because the motor actually runs better with it on. And you can also see by looking at this that my magnets aren't perfectly spaced on my rotor. Terrible building, I guess. But I'll spread it out here a little bit here too. And now let's run it. Let's just stop it here, and you can see what the waveforms look like. And stop, froze, real time. We're back to running again. But looking at it here again, now it's spinning. Probably 180 to 200 RPM, just guessing looking at it. But it's the same motor. The quickest way of adjusting it is to adjust it for rocking back and forth, and then adjust that rock for the biggest amount of rocking. And at that point, you'll have the motor set up properly. I'm beginning to have some suspicions about this toroid coil and other ways to do this more efficiently. But the motor is gradually spinning up, just doing its little thing. And let's look back down here at the waveforms again. And I want to look at the voltage on the core. On the coil. I believe I'm on. I was on AC there. Bring it up a little bit more, and let's even increase it some more on the gain to look at the pulse. You can see the back EMF down here at the bottom. Let's freeze it, and that's the back EMF when the thing turns off, that the diode integrates back into the coil. And gosh, there's a good picture of it right there, and you can see the voltage. We're now on 2 volts per division on this. So I can spread this out. So this is about a little over 1 volt, where the clipping action of the diode comes in here. But you can see the area right there. That back EMF is virtually nothing compared to the size of the waveform. So you can learn an awful lot from a good scope. And I froze it there now. You can also, if you notice right up here, this is where the coil charges up, and it shows a very steep standard inductive charge curve, and when it turns off due to the low effective inductance, it actually just switches bam. But that effective inductance, because it's wound in a quadrifilar form, really provides a voltage punch. So anyway, you live and learn a little bit. I think now this afternoon I'm going to, you have all these wires loosened here where I tied each individual coil together to the driver. I believe I want to build my little driver circuit over here on a piece of perf board along and integrate the Hall effect detector mounted up here overhead, where I can have a much more and tie the coil down so it doesn't move around when things are honky. Center the coil up and tie it up and make it much more presentable. Today it'll take 2 or 3 hours of me puttering, taking a nap, etc., etc. But it runs very well on 12 volts now once you understand how to adjust the thing. And I think it would probably run on 7 or 8 volts, which lowers the current. We're seeing quite a bit of coil heating due to the average power in this. We have really close to a 50% duty cycle at times. Most of the time it's about a 40-60 on to off. And so you end up integrating about 4 or 5 watts into the coil to get it to do this switching during the what I call the Adams effect switching, which is a masking or cloaking effect where it hides the coil when it turns on, allows the motor to coast pass. There might be some eddy swirl forces generated in here, but I cannot see them and I can't prove it, so I tend to stick to something that I understand. And so that's it. I'm kind of muddling on and burbling here, so it's time to shut this thing down and say this is K4ZEP from the world's smallest lab, and I'm gone, and Happy New Year, y'all.